In this video, we're going to be solving a system of linear equations and determining if the system is consistent or inconsistent. So let's first talk about how many types of solutions there are. Well, when solving a linear system, there are three types of solutions. You could have one exact solution, you could have infinitely many solutions, or you might have no solution. This is what helps us to determine if a system is consistent or inconsistent. If there's exactly one solution or infinitely many solutions, that is considered to be a consistent solution. So whenever you have at least one solution, it is consistent. But when there is no solution, then it is inconsistent. Let's go ahead and let's solve this system. So here we have 6x minus 5y equals 3 and negative 12x plus 10y equals 5. I'm going to be using elimination to solve this system. So I'm going to be looking at my x's and my y's and determining which ones will be easier in making a matching opposite. Now, a matching opposite would be something like 5x and a negative 5x. They're matching in that they're both 5x's, but they're opposites because one is positive and one is negative. So in this situation, I don't think it really never matters which one you choose between x and y. So I'm going to go ahead and I am going to make the x's match. So in order for that to happen, I'm going to have to multiply by a positive 2 because I want those to turn into a 12. So I'm going to multiply my top equation, all three pieces, by 2. And that is going to give me a 12x minus 10y equals 6. And then I didn't do anything to this second equation, so I'm just going to write that down. Sometimes you have to multiply the second equation by a number to get them to be able to match, to find that common multiple. All right, so now that we're here, we're going to add these two equations together. So 12x plus negative 12x is a 0, and so those cancel out, which is exactly what we were trying to do. We were trying to eliminate our x variable. And now we have negative 10y plus 10y. Well, we've eliminated that as well. So here we're going to have a 0 equals, and 6 plus 5 is 11. So in this particular instance, 0 equaling 11 is not true. Like that, it's not true. And so when that happens, we find that we have no solution. So we've found our solution, that it's no solution, and so now we need to determine if it's consistent or inconsistent. So in this particular case, because it's no solution, we find that this is an inconsistent system. So no solution and inconsistent. Let's go ahead and do another example. All right, so now we have 1/2 x minus 1/8 y equals negative 3/8, and 4x plus y equals 3. So notice that this one's a little bit tougher. So same thing, I'm going to look at the x's, I'm going to look at the y's and determine which ones I think might be easier to get to cancel out. And I'm going to go ahead and choose the x's again this time because they're smaller numbers. So what I'm going to look at is, gosh, what can I multiply my top equation by right here so that my 1/2 x will somehow turn into a 4. And so what number times 1/2 is 4? So basically, if you take half of what number, will you get 4? So what's 4 times 2? 8. So if we multiply this by an 8 to all three pieces, that should help us. So half of 8 is 4. So 4x, and 1/8 of 8 is a 1. So minus 1y, and then equals, and then 8 times negative 3/8 is a negative 3. Now, if I wanted to, I could have used my calculator to find each of those as well, and that would have been just fine. Now I'm going to write down my second equation. We didn't do anything to that, so I'm just going to go ahead and get to write it right down. And so here, as we're looking at those, 4x plus negative 4x, well, that cancels out. And negative y plus y cancels out. So we're going to get a 0 equals, and negative 3 plus 3 cancels out, giving us another 0. But unlike last time, 0 equals 0 is actually true. And so this tells us that we're going to have infinitely many solutions. And when it comes to that, because we have at least one or more solutions, this is going to be consistent. So this is a consistent system.